solving quadratic functions. Whenever we're just trying to solve the quadratic functions, we can do it in different methods. We can do it in different methods, just like what we have studied in solving linear equations. We have observed that there are some different techniques. There are some different methodologies to solve that linear equation. But we just same as that. Similarly, analogously, we can also tell that we can solve any quadratic functions just by using different techniques. For an example, one of the easiest and most useful and the most common technique is factoring quadratic equation. This is basically what we do. We just factor. We just write this polynomial. We just try to express this polynomial into two products, and then we just make them equal to zero or equal to 0. This is equals to 0 or that equals to 0, and then after that we get the solution. But not all the time we would able to factorize a polynomial quadratic equation, because that's not possible all the time. You really cannot do the factorization for each and every single polynomial. So the thing that you really need to do, that is basically the quadratic formula. But we will come to that later, rather than following the very next topic, that is squared root method. Squared root method. What is basically the squared root method? If a quadratic equation does not have an x term, you may want to use the square root method. I don't think this is nothing but some simple mathematics. Just by taking this negative 16 to right side and then doing a root or whatever.
Square root. Yeah.
Square root, right? Just doing a square root. I don't think. Forget all the rules. Forget all the rules. This rule, that rule, this rule is called that, this rule is called XYZ, this rule has a particular name, this rule is called square root method, this rule is called quadratic formula method. Forget every single names. Just practice, practice, and practice. Take notes, practice. Take notes, practice. Take notes, practice. Take notes, practice. Because that's the only way. Because you really don't need to mention what type of method you've really used here. Because so many times they are doing a problem in a very clever way, but that's not the exact way of doing this mathematics. For an example, that particular math problem, but they're not asking you what method you've really used. So you just need to write the notes so that you can remember how to solve a particular problem, but you don't need to write on the exam paper what method you have used. So practice is the only way which can really tell you which method is going to work on which time, which method is going to work on which time. So simple. I really don't need to memorize the square root method. Just taking this side, just taking this negative 16 to the right side, and then doing some square root. That's it. Simple as that. Just as simple as that. Okay, just focus on this problem. X minus 3 equals root over plus minus root over plus minus root over 25. This is basically plus minus 5. So x minus 3 is equals to plus minus 5. X minus 3 is equals to plus minus 5. So,
Oh, yeah.
so, so what to do now? We just need to work on. We have already talked to you in our absolute value class. In our absolute value class, we remembered that when you are just trying to get rid of the modulus sign, whenever you are just trying to get rid of the modulus sign, you really need to put a plus and minus simultaneously at the same time for that modulus sign. Just like for an example, you have just broken a traffic rule, and then you are just fining because you have just broken a traffic rule, and that's why you are just giving some fines. You got me, right? You got me. So
Yes.
when you are just getting rid of the absolute, because for an example, the modulus value of 5 equals plus minus 5. Can you please just recall? The modulus of plus 5 is equals to plus minus 5. The
Yes.
modulus of 5, the absolute value of 5 is equals to plus minus 5, because we're just trying to get rid of the absolute value symbol. We're just trying to get off the absolute value sign. So we're just giving some fine, we're just giving some bribe, just giving some bribe. Man, just take it and please let me get rid of this absolute value sign. We're just taking the plus and minus each time simultaneously, and then we're just getting rid of the absolute value. So why I'm talking about this absolute value? Because the thing is, you just need to, whenever we just talk about, we taken the absolute value problem, we solve the problem that we need to work separately, individually. We need to work separately and individually for this problem, because we, first of all, we need to talk, we need to perform the mathematics for +5 of the right side, and we need to perform the mathematics for the -5 on the right side. Then set up two equations to solve the potential value of x, just like they're just taking +5 on the right side. First of all, they're just taking the +5 on the right side of this equation, and then they're definitely taking -5 for the right side of this equation. You got me, right?
Yes.
What I'm just trying to tell you, why I have just taken the +5 and the +5 and the -5, because we're just taking separately. We're solving separately for the +5, and we're just solving separately for the -5. We're solving, first of all, we're solving for +5, and we're solving for -5. You got me, right?
Yes.
The same thing we also did for the absolute value. The same thing we also did it for absolute value. Whenever you're just watching something like this really means that we are just gonna get two values of the x. We're just gonna get two values of the x, and some basic mathematics tell us, a quadratic equation doesn't really necessarily mean that we are just gonna solve one solution. Definitely we are gonna get two solutions. Because the exponent, the degree of these polynomial is 2, and that is why we are calling this quadratic equation. And the polynomial 2, the degree, having the highest exponent 2, definitely we are just gonna get the values of x is 2 different values, and that is the fundamental theorem of algebra. In our calculus class, we will look on that we have a theorem called the fundamental theorem of calculus, and we have also a theorem called the fundamental theorem of algebra, which is covered in the algebra text, that tell us that the degree of the equation is the number of solutions we are getting after solving the equation. The degree of the equation tell us the number of solutions we are gonna get after solving this equation. So the degree of this equation is 2. So definitely it means that we are gonna get the solution 2. We are gonna get two different solutions, maybe two different solution or two same solution, whatever it is. We are just gonna get two solutions. You got me, right?
Yeah.
If does it really seems to be not understandable? Does it seems to be not understandable? Do you understand me what I'm talking about?
Yeah.
Okay, so what about having the degree 4? Just think about x to the power 4 minus 9x plus 20. How many solutions we are going to get that? No, x to the power 4 minus 9x plus 20 is equals to 0. Then how many solutions for that equation we will gonna get there? We will gonna get there for x to the power 4 minus 9x plus 20. Think
4.
Yes, definitely, exactly. We're gonna get 4 different solutions, maybe 4 different or 4 same, whatever it is. We're just gonna get 4 solution for that equation. That is the fundamental theorem of algebra tell us. And solving a quadratic equation means that we're gonna get 2 different solution or 2 same solution, whatever it is. We're just gonna get 2 solution. We're gonna get 2 solution. And what is a solution? A solution is just nothing but solve the value of solving after we get after equation. This is a solution. +4 is a solution, -4 is a solution. Please don't think like that this plus minus 4 is intrinsically just a single number. No, definitely not. This is, we are just writing the +4 and the -4, the +4 and the -4, just in a packet. For an example, sometimes we eat some kind of food that comes with just like a packet, and just packet food or such kind of food, you just get everything in one single packet, right? Platter
Yeah.
or something like some dishes, just like you just get everything in one plate. You get everything in one plate, right?
Yeah.
So this is basically just like a packet. So x equals plus minus 4 means that the value of x is plus 4 or negative 4, positive 4 or negative 4. You got it?
Okay. Yes.
Please don't make that mistake. Please don't make that mistake.
Okay.
We are just writing plus 4 or minus 4 simultaneously, just in representing it shortly in a very simple term or in packaged term. And whenever we are just solving an equation, a quadratic equation, we are just going to get two solutions. Definitely we are going to get two solutions. Okay, we're definitely going to two different solution. I think you know that this quadratic formula, this is basically a formula which is used to solve the value of x, the
Yeah, I know
variable,
that.
the variable of any kind of quadratic equation. So you just need to memorize this equation, memorize this formula, memorize this formula. Maybe you just need to memorize it, or maybe the question setters, maybe it will
Oh,
be
I know
provided in the
that.
questions. Okay, but the thing is, applying it requires sometimes a lot of time, because this is not a very shortcut technique, or this is not a very short term things. We need to do a lot of things here, so maybe it's not helpful all the time, maybe for the set mathematics, but this is one of the most fundamental formula for solving the quadratic equation, the quadratic formula. We call that the quadratic formula.
Mhm.
You can solve this equation by using the quadratic formula. Plug the values in this equation. As an example, we just need to solve this equation. We just need to solve this equation by using the quadratic formula. The only thing that we can do just the exponents, the exponents for x squared, the exponent for x, and the constant term into this formula, and we would get a value. We would get a value just like this. So they're just doing this. I think you know this, right?
Mhm.
Okay, you know this. But the same thing again. X is equals to negative 5 by 6 plus minus 7 by 6, right?
Yeah.
So this is a packet. This is a packet of two numbers. This is a packet of two numbers. A packet of two numbers.
So that's the two different solutions.
Definitely, 100%. Definitely, two different solution. Sometimes maybe the numbers are same. Sometimes maybe the numbers are same. Maybe. In some cases, maybe this is not a rigorous mathematics class, so we are not going to talk about that. When we get the same solution, for a quadratic equation, that is kind of some advanced. That will be advanced, but we're not going to talk about that. But whatever it is, you are just going to get two solution, two different numbers after solving a quadratic equation. We're getting one number, this is the one number, and this is the another number. A number is a solution. A solution is just a number. A solution is a number. It represents the value we get after solving the equation. What is solving? Finding out the values of x. What is the solution? What is the solution? The value of x. And what is the meaning of solving equations? That necessarily means that we need to find out the value. We need to find out the values of the x, values of the variables. So you are just doing negative 5 by 6 plus 7 by 6. We are taking plus 7 by 6 in one case,
Mhm.
and we are just taking negative 7 by 6 in another case. You got it? Or you
Yes.
don't get it?
No, this one, yeah.
And you cannot use calculator because maybe the calculator is not approved here. I really make mistakes when in what sections the SAT authority is gonna give you the calculator and not, because I exactly don't remember. But you have to keep the habit, you have to build up the habit to do these things in just without using any kind of calculator. You got me, right?
Yes.
Okay, so practice. We will really talk about homework later, but uh, the bad news is a really tough homework is coming waiting for you. So I'm sorry, but we need to do that. Uh, Completing the square, and same thing. Stop memorizing or stop knowing about so many different types of headings completing the square. You can take notes. You can just, this is a fancy term, but maybe this is not helpful. This fancy term is maybe not helpful. How to solve this equation? Simple, man. Just simple. Just, you can, whatever it is, you can just, they're just trying to, maybe they're just trying to tell you that this equation can form a plus b whole squared form. Maybe they're just talking about that. Maybe they're just talking about that, but you can also solve it just by using the quadratic formula. Just by using the quadratic formula, or maybe sometimes if the quadratic formula is time taking, if it is really taking time, then definitely you can solve it. Then definitely you can solve it by the plug-in technique. Use that technique. Maybe that technique is really helpful sometime. Maybe that problem. So they are trying to solve this problem by completing the square. To solve this equation, first take half of 8, which is 4, square it and add it to the both sides of the equation. So that is what they're trying to do. Yeah, okay. So they're just trying to make this term of this right side of this equation, to write it as a plus b whole squared, a square plus 2b plus b square. They're just trying to write the left side of this equation. They're just trying to write the left side of this equation in such a way, that it really gonna give you, a whole square, formula, a whole square expression, just like what they're talking about. This is our exact equation, what is given in the problem: x squared plus 8x equals 20. So if we are gonna add plus 16 in this side, and if you are going to add a plus 16, why we are adding plus 16 on the both side of the equation? Because we are interested, we are really interested, we are highly interested to make this expression on the left side of this equation looking or writing like a plus b whole squared formula. A plus b whole squared formula. You got me, right? So
but where's the 16 coming from?
the 16 is coming from, because we are just adding 16 in order to make the equation, in order to apply the rules of a plus b whole squared. We are just adding 16 both sides. We can add same terms both sides of the equation. We can subtract same terms, same value from both sides of the equation. We can divide it both sides. Whatever we do, we need to do in the both side of the equation. Whatever we do, we just need to do every single side of the equation. We just cannot add 16, or we cannot just add a particular number on each side. Definitely that's wrong. That's the main concept of equation. That's the main concept of an equation. Whatever you just do both side of them. Whatever you do, you do both side of them. You're just adding 16 on this side, you're also adding 16 on this side. And the reason that you are adding 16 on this side, because you just need to make it look like this. How this is coming from this? Because x squared plus 8x plus 16, x squared plus 8x plus 16 can be written x plus 4, x squared plus 2 into x into 4, x squared plus 2 into x into 4, 2 into 4 equals 8, plus 4 squared, You got it?
Yes.
X squared plus 2 plus x squared plus 2 into x into 4.
Oh, yeah.
Plus 4 squared.
Oh, okay.
Plus 4 squared. And that is what we can tell. X plus 4 whole squared equals 36. And just solve it. X plus 4 equals plus minus root over 36. Plus minus root over 36. Always remember that a square root would definitely carry a symbol plus minus. You know that?
Yeah, the plus minus.
Definitely. Root over 36 means that plus minus root over 36. So solving the plus minus 36 equals plus minus 6. So this is the thing. x plus 4 equals plus minus 6, and solve it separately. Solve for the case 1, x plus 4 equals plus 6. The case number 1 is x plus 4 plus 6, case number 1. And the case number 2 is x plus 4 equals negative 6. X plus 4 equals negative 6. Case 1 and case 2. Things will become more transparent. Things will become more transparent when you are just solving with your own hands. When you're just going to solve these problems with your own hands, things will get really too much easy. Solve each of these using completing the square. Whenever you're just facing any kind of problem in any kind of mathematics, please send me, I will solve it. Please send me, I will solve it. But you just need to go through these problems, because if you really do not practice, SAT textbook won't really teach you any kind of mathematics, the rigorous mathematics, the fundamentals of mathematics. It will just tell you how to be a technician, how to be a clever person to solve the mathematics of SAT. But to know about mathematics, the rigorous mathematics, you really need to go. You really need to dive into the rigorous mathematics textbooks. And to carry on a good number on SAT, to carry on a good score in SAT, you really need to practice more and more. And to practice, how to practice? Go through every single examples, go through every single practice problems, solve them, and cross-check them whether you have done it correct or whether you have done it wrong. And most importantly, try to think about that problem. If that problem solving the problem that you are solving in such a way, in the method, the problem that you are using, or sorry, the method that you are using to solve the problem, is that efficient? Is that time saving? Is that time efficient? Is that really going to save you some seconds or some minutes or not? If it's not helping you in the clock, if it's not really helping you to solve the problem in a short amount of time, then please think about a new different way to solve that problem. Please think about a new different way to solve that problem, which is gonna really be time saving for you, because saving the time is the most important thing for you. For an example, you're just gonna, if you're really gonna solve this problem in this way, 4x squared plus 3x plus 1, you have to get the intuition, you really have to make such understandability, you have to really make the capabilities to understand that man, that to solve this problem in the rigorous techniques. For an example, we have read out so many different topics, so many different techniques of solving a quadratic equation, is not going to help us that much. Rather than do some plug in techniques, that what they are just going to maybe talking here, no, they're going to talk about that later. But if this problem really appears in your test, in your SAT test, I don't think using the quadratic formula or using any of the techniques that we have already read it is not that much efficient, that not much time saving. The only thing you can do, that is you can do some option test method. You got me?
Yes.
That will gonna help you. So how to understand that when method is gonna work on well? Practice. You just need to make these problems of your cup of tea, so if you are really if you really want to make these problems just like liquid, just like water, then go through these problems again and again, try to think about them, and that is the only way. Then you will automatically understand, because I'm not someone who was so good in mathematics, but I'm just thinking, it is just clicking just by looking 1 second for on this problem, then that is, it's not an efficient way to solve this problem in the SAT test using the quadratic formula. Because rather than we can solve it easily, to check out the plugin techniques, maybe the plugin techniques or the another kind of method. Okay, so you just need to do it, because just look at this solution. They're not using the quadratic formula, but they have just completely ruined the problem. You cannot do it, man. You really cannot use these things, because if you're really gonna do this problem in this way, if you really try to solve this problem in this way, you really just cannot do. You're really gonna need to sacrifice at least 5 problems in your SAT test. This is gonna be a very time-taking process. You need to be super efficient. because the SAT authority is not going to ask you which method are you using for this problem. No, they're not going to ask you that. They're just going to check it out whether you've just filled out the correct circle on the wrong circle. This is OCR. Okay,
Mm.
this is OCR based MCQ problems. So you just need to use your cheeky tricks, your clever techniques. Don't try to be a mathematician here, because your true love in mathematics will not really that much help you. Maybe that not much help you to carry on a good score in SAT, rather than to understand the mathematics, the real mathematics. You just need to be a little bit clever. That's it. That's the main thing of any kind of competitive, any kind of test, any kind of aptitude test or something like that, whatever you were just talking about, GRE, or whatever you were just talking about, GMAT or SAT. So okay, this is the thing that they are really telling us, that we just need to plug in the answers sometime, or the option test, which we really already told that. So option test, yeah, definitely. Really, we can solve this problem. We can solve this problem by the rigorous techniques of mathematics. But maybe that's not going to help us. That you're just going to do some option test problem, option test technique. I'm sorry, option test technique. Put the value of x as 1. 1 divided by 1 plus 2 equals 3, plus 3 divided by 2x plus 4 equals 6. 3 divided by 6. 1 plus 1 divided by 3 plus 3 divided by 6.
Mm-hmm.
So I'm just doing just by using my imagination technique, because I am really not using any kind of pen and paper. But you can just do some shortcuts. Starting with 2, trial and error. This is a trial and error. Basically, trial and error is a very important technique in engineering. Maybe you will learn that why we really use trial and error, because trial and error is one of the most efficient technique in any kind of back calculation or back engineering. Whenever you're just trying to figure out what is the main underlying things lied here, you just need to do some things like this, the option test or plug-in technique. You got me?
Yes.
I really cannot go through every single example and try to make you understand, because that is not really gonna help you.
Yeah.
If you really gonna carry on a good score, the only thing you really need to go through, that is basically solving too many problems.
Mm.
Because I really cannot help you much more than this. If you're gonna ask me, please help me more, then I can give you some notes on some fundamental mathematics. But I really cannot help you more than that, because you really need to solve these problems on your own hands.
Okay.
Okay, so just they're just trying to plug in to solve this problem. They're just suggesting us to use the plug-in technique. So 4 into x minus 2 whole squared plus 2 equals 2x. So how to solve this problem? You can solve it in so many different ways, but I don't think the most efficient way is to use the plug-in technique. So test with 1, test with 2, test with 3, test with 4. So rather than, whenever you are just trying to use the plug-in techniques, just try to a little bit assuming, because so that you are not just necessarily be using so many different trial and error. Because if you are just gonna get the option D, then you're just gonna carrying on the operation for 1, for 2, for 3, for 4 different trial and error. 4 different trial and error is gonna be so much time taking process. So rather than try to look at the equation and think about what gonna be the solution, man. What gonna be the solution? For an example, just think about taking this 2 on the right side, taking this 2 on the right side, and then think about, what about this, what about this. You really just cannot if you what about taking 2? Because if you really gonna take 2 on this side, take 2,
On
then
the other side.
on the left side, 2 minus 2
Yeah.
is gonna be 0, and
Yeah.
this thing is gonna be um, 0. This thing, this
Yeah.
4 into x minus 2 whole square is gonna be 0. So before doing it on your pen and paper, using pen and paper, just gonna be a little bit clever and use your brain. I'm sorry for the noises that are coming from my sides. I'm really sorry for that. But the thing that you really need to do that is basically you just need to be a little bit clever. You really need to be a little bit clever. I think using 2 is not going to be our first choice. Rather than try to use 4 or 1, maybe using 4 or 1 can be more beneficial than using the 2, because if you really work on 2 for the first time and then you are working on 4, that's going to be a time taking process rather than start with taking 4, because it's 100% sure that both there will be just a single answer on this option. It's not possible that the option A, option B are going to be the correct answer for this equation. You got my point, right?
Yes.
This is an identical solution. So the option will be there will be an only option available in the options. There will be an only one option available in the options that is correct. Simultaneously, 2 options cannot be correct. So if the bullet for the first time hits in the right place, man, we have cracked it. We have cracked it in the easiest time. In the I think they are not using 2, so basically C works nice. So being clever, okay? So
Yes.
we're just interested in undefined functions. We are going to talk about that. So what basically undefined means, that is it is undefined when you just try to divide something by a 0. That is basically undefined. That is basically undefined. Actually, there are so many concepts relied on these type of undefined, indeterminate forms, and etc. in the calculus. Maybe you are just covering the pre-calculus section, and you are being taught there that there is a form called undefined form and there is a form called indeterminate form, and we have so many different type of forms like this. And an undefined function does not necessarily mean that not mean anything but when it is uh, being undefined. An undefined function means that when it is being undefined. An undefined function means that it is whenever it is just becoming undefined. And when it becomes undefined, this is basically a rational function. If you have ever heard of a rational function, then you will understand that basically one of the topics that is covered in the functions chapter. And this is basically a rational function. I'm not interested to talk about rational functions here. Rather than, I'm just interested to talk about when this function will become undefined. The only time it will become undefined when we are just getting 0 in the denominator. When we are just getting 0 in the denominator. And when it will become undefined? It will become undefined when this denominator x minus 4 equals 0. When this denominator x minus 4 equals 0, it is becoming undefined in that time. So what does that mean? That means that you just need to really equate, or you just need to assume, because we're assuming that it will become undefined when when the x minus 4 equals to 0. And solving this, we get x equals 4. So when x is equals to 4, we are getting this function as undefined. And most importantly, we have different type of functions. That we have already talked about. Maybe you are not quite familiar with one function, one many function, polynomial function. You are quite familiar with polynomial function, but I don't think I have talked about when an polynomial function becomes undefined or not. Actually, the thing is, a polynomial function never becomes undefined. It never becomes undefined. It never becomes undefined. It never becomes undefined. A polynomial function never becomes undefined. But this is a rational function, and a rational function is not a polynomial function. Actually, a rational function can become undefined, but a polynomial function really cannot become undefined. A polynomial function is just the portion this. You can just tell this as a polynomial function, x cubed minus x squared plus 2. This is just a polynomial function. It cannot become undefined. It really cannot become undefined. But this whole thing, x cubed minus x squared plus 2 divided by x minus 4, this can become undefined, because this is a rational function. So a rational function can become undefined, and you will get the rational function undefined when the denominator is 0. And this is a concept of undefined. When you try to divide something with 0, you just get an undefined. And there is a form called indeterminate form. Those topics are covered in the pre-calculus section, and maybe if our schedule permits, we can also talk about that. But right at this moment, you just only need to focus on this, that a function will really become undefined when the denominator is 0. Okay, have you got my point? Just
Yes.
focus on this problem. Focus on this problem. That is basically 7 divided by x squared minus 9. So then denominator is becoming 0, and that moment the function is becoming undefined. And what does that really mean? X squared minus 9 equals 0. So if you solve for the values of x, if you really solve for the values of x, just consider x squared minus 9 is an equation. I need to solve that equation. This is the quadratic equation, and this is a very baby problem, and you just need to do it. Whatever, you just don't make it complicated. Don't try to use it. Don't try to use the quadratic formula, because using the quadratic formula will not help you. This is a very simple problem. X squared equals 9, so x equals to plus minus 3. You got my point, right?
Yes.
We can solve a particular problem in so many ways. We can solve just a particular problem in so many ways, and that's one of the beauties. That is one of the beauties of mathematics. But that necessarily not mean that you should try every single process in every single time, because SAT is not going to test you how in-depth knowledge you have on mathematics, rather than how many problems you are doing correctly in one single attempt. That is the only test here. That is the only test here. So don't try to apply the quadratic formula. Rather than keep the problem simple. X squared equals 3, x squared equals 9, so x equals to plus minus 3. So the function will become undefined when x is equals to 3, or excuse me, x equals to negative 3. And most importantly, a function can really become undefined in multiple points, just like this: 3 plus 3 or negative 3, positive 3 or negative 3. Can you see that?
Yeah.
Because after getting the values of x, solving the equation x squared equals 9, we are getting x equals to plus minus 3, x equals to plus minus 3. We are getting two different values. We're getting plus 3 and we're getting minus 3, and that is necessarily indicating us that this function can be undefined in two different points. Okay. Extraneous solution is something when you really get a solution by your extra things that you are really doing on on a particular math. Because an extraneous solution is basically something when you are just for an example um, for an example, some people like to have their tea. Some people like to have their tea. Basically, I'm a tea loving person. Some people have to like their tea not having in a cup or a mug, rather than having on a bowl. There are so many people who have some different type of traditions in their locality, or different type of cultures in their locality. A lot of times they really prefer to have their tea rather than having in a mug on a coffee, a mug or a cup, rather than having it on a bowl, a very thin bowl. Okay, so why I'm talking about this? Because you're just doing an extra thing for an outside of the tradition, because we're really very comfortable, and we're really supposed to have the coffee on a mug or a cup, but you are not doing that. You are just using a bowl to have the coffee or of the tea. So that is an extraneous job, and an extraneous job will give you an extraneous benefit or extraneous taste, and that is what we are just talking about. An extraneous thing will give you an extraneous output. So you are just doing some extraneous things in an equation, and that thing will really cause you, or give you the outputs of extraneous solution. And for an example, what is the meaning of doing extraneous jobs? This is just, I'm just talking in a very, I'm just talking about in a very just in a very analogous way. Okay, you know, because this is not the exact mathematical language, because the exact mathematical language or exact mathematical definition is a little bit more complex, complex and complicated. So I'm just trying to use a some examples, some real life phenomena. How do you solve that? If you really solve this problem, you just need to get out of the tradition. If you really want to get out of the tradition, if you really want to stay in the tradition, in the real mathematical in the real mathematical process in the real mathematical process, then you can really solve it in so many different ways. But if you really try to handle this situation in a more little bit uh, more casual way, in a casual way, then the thing that you really need to do, that is basically you just need to square in the both sides of this equation, and that is an extraneous job. Are you understanding my points?
Yeah.
You just need to do some.
But
So okay, please continue.
okay, but what would the solution be though? Like just any number?
Yeah, definitely. That is the main thing of solving any kind of equation. You will get any kind of you will get a number. You will get a what is the meaning of a solution? A solution is nothing but just finding the values of the variable, finding out the values of the variable. And if we solve if we solve this equation, we're just trying to solve the values of the x, and that is called the solution. And to do the solution, we are not really interested to excuse me, we're not really interested to solve it in a very very crazy critical mathematical way. So that's why we are using this casual way. We're just using this casual way, and this casual way is involved doing some extraneous jobs, just like having the tea on a bowl, not having in the cup, in the mug. And that extraneous job will give us some extraneous benefits or extraneous tests. For an example, that taste of having the tea in a bowl rather than having on in a mug, and the thing will really gonna cost you some extraneous outputs. And then how that extraneous outputs really look like, because you're just getting some extra things which are not really relevant in this situation. And in the context of mathematics, that is, we are just doing the square in the left side of this equation and the right side of this equation. We're squaring, and after we are squaring this root over x minus 1, we are getting x minus 1, because the root is cancelled doing the squaring. Are you understanding my situation? Are you understanding what I'm talking about?
Yeah,
You're just squaring this
kind
side and
of.
you're just
Yeah.
squaring that side. You're just going to square this side and you're just going to square that side. Left side and right side. You're going to square both sides of the equation. Both sides of this equation. You're just going to do the square in this side, and you're just going to do the square in the right side. And after
Yeah.
you are doing that, you're getting this. You're getting this. Is it clear?
How did you get plus 49?
Plus 49, because you are just doing x minus 7 whole square. A square minus b square, a square plus minus 2ab plus b square.
Oh, okay.
X
So
minus 7 whole square, x minus 7 whole square, a minus b whole square. Okay, a minus b whole square. We are just gonna stay in page 39. Page 39. Don't forget this. Please don't forget this.
okay.
This is basically a product. This is basically a product expression, but but actually actually the thing is how can I make you understand? Okay. A minus b whole square. A minus b whole square. This is a and this is b. A minus b whole square. And after doing a minus b whole square, you're getting this.
Okay.
Are you understanding me?
Yes, no.
Okay. Okay, all right. So then you just need to do the simplification of the equation, and you are just doing the simplification of how you are doing the simplification. Just taking x squared looking terms in the one side and the x term consisting of the x term x variable on the other side. This is what the simplification will look like this. Like this, you are just taking x squared one side, you are just taking this negative 14x and this x, combining them into one single term. Are you getting me?
Where did that x go on the other side?
The x is going, this x is going to that side. We are just trying to simplify this
Oh,
expression. We are just trying
oh,
to simplify this equation because we are not interested to keep so many different x. This is
yeah.
negative 14x and this is plus x. This is negative 14x and this is plus x. So there's
Oh,
no
so you
point
just
of,
add. Oh,
yes,
okay.
so there's no point of keeping so many x because
Yeah.
these all are same variable x, but they're just made up of different coefficients. So what's the point? This is just
Mm.
nothing but foolishness. So definitely simplify them. That's the only way to do it. Simplify them, and that is what we're just trying to do. And then we're just trying to factorize. We're just trying to make them product. We're just making them factorizing. This is factorizing. Do you know the method of factorizing?
Oh, I think.
Factorizing means that you just need to express this equation. You just need to express this equation into like this in the products. And how to do
Oh,
that?
yes, yes, yes.
Have you ever heard of middle term break method?
I don't know, but we did it like find two numbers that multiply to one of them and add to. Yeah,
Exactly. Because you just need to make it factorize. You just need to do the factorizing. You just need to do the factorizing here, here. And after doing the factorizing, you are just getting these two products.
yeah.
You are just getting these two products, and the potential solutions are 10 and 5. But the thing is you are just getting an extra solution because the very first line where you started, you are doing an extra squaring. Are you understanding my situation? Are you understanding what I'm talking
Yes,
about?
yes.
This was our problem basically. This was our problem. Root over x minus 1 equals x minus 7. This
Yeah.
was our problem, and we need to solve this problem. And the easiest way and the casual way to solve this problem, the casual way to solve this problem is by squaring in the left side and squaring
Mm-hmm.
in the right side.
Mm-hmm.
And if you do that, you are just getting an extraneous solution. You are just getting an extra thing which is not relatable and which is not valid. And this is basically completely and this is basically just coming as a byproduct. That is coming as a byproduct. That is not what we are looking for, but that is basically coming just by doing this squaring. Just by doing this squaring, because whenever you are just doing this extraneous job squaring, we are just calling this squaring, performing this squaring in this side and this side. We are just calling this extraneous job, and this extraneous job is just gonna is just gonna is just gonna create a new problem. Create a
Mm-hmm.
new problem because we are just getting too many different, because we are just getting an extra solution which is really not relatable. Now, to be sure, we don't have any extraneous solutions. Plug 10 and 5 back in to the original solution to see if they work. If they work, because we have just got 10 and 5, two different solutions. We have got two different solutions, 10 and 5. But will they work or not? Will they work or not? And to check out that, we just need to plug in, because we are just trying to do an extraneous thing, that was our squaring thing, that was basically performing the square on the both sides of the equation, and that is gonna cost us, by getting an extra solution which is not the solution of the equation. Have you got my point or not?
Yes.
I hope you will come to know, because if you're just gonna solve these problems hands on your problem with your own hands, pen and
Mm-hmm.
paper, you are just gonna understand. Because just look at this, 10 and 5, 10 and 5, and we are just trying to plug in this 10 and 5 in this equation. 10 minus 1.
Yeah.
We're just trying to plug in these 10 and 5 in this equation. First of all, we're just going to plug the 10 and then we're just going to plug the 5.
So we're trying to see which one is the answer.
Exactly.
Yeah.
Which one is the exact answer and which one is the not the answer, but we are taking or we are just writing it as an answer, but that was our wrong. That was the wrong of the process, and that is the wrong of the process, and that is the output or the byproduct of the wrong process, and that is why we are calling them as the extraneous solution, because that's not the exact solution or that's not the correct solution, that's a wrong solution, but that is coming out with the byproduct, that is coming out as a byproduct, and that is coming out as a byproduct, and that's why we are calling that as a extraneous solution, because that's not the solution, but that is coming as a cost, as a gift, but we really don't want that gift. That is basically not a gift, but that is coming just like a sometimes suppose buy one get one free, buy one get one free. You got my point? Buy one get one free. You just buy a new shirt and you are just gonna get an extra shirt, but we are not really interested to get the extra new shirt, because the extra new shirt is really not gonna be suitable for me. So that is an extraneous shirt for me. Buy one get one free. So that extraneous shirt is not for me. So we are just trying to get rid of this extraneous shirt, which was given us fully free, but we are not interested to get them in free, and because that's not the correct solution, and that's why to check out which one is the correct solution and which was the wrong solution, we are plugging in and we're just checking. Have you understood?
Yes.
Okay, so the thing is we have the synthetic division. We have the synthetic division, which I will cover in the next class, which I'm going to cover in the next class, the synthetic division. And but just taking up but just talking about what we have just what we have just studied today, I'm just gonna do a small recap. So please formally our classes have been over today, but I'm just gonna see what we have studied. We are basically started with polynomial and factorings. Basically this is a section, and this section is consisted of different chapters, and this first chapter was polynomial manipulation, and we have learned about polynomial manipulation and how does it really look like and what it really means, that simplification, nothing but the simplification. And then we have done the factoring things and squaring of binomials. This is basically some basic rules of algebra: a plus b whole square, a minus b whole square. Please recap those things, recap those equations, and do the problems. Please do the examples and do the practice problems. Please do all of them worked out. So you have some extra practice drill problems, polynomials and factorings. Do all of them, definitely. Think about them. Maybe you just need to do it. You just don't need to do it hands on each and every single problem. Look at them, think about them, and think about how to solve them, because if you are going to use pen and paper for each and every single problem, then you are not just going to cover every problem. It's not possible. Rather than focus on how to solve them easily. Okay, so problem 10 is a little bit a tough problem, so try to solve it. And if you're not going to tell me which problem in your facing problem, in which problem you're just going to facing problem, which in which problem, then I won't understand that you have really practiced. Exponential rules, we have also covered that. Problems with exponents and roots. Practice these problems. Please practice these problems. Very important. Very important.
Also, is this the which PDF is this, the Baron one? Or the
yeah, this is gonna be the Baron. This is the Baron's.
Okay.
I'm gonna give you this particular PDF.
Okay.
I'm gonna give you the particular PDF, and most importantly, I'm gonna give you a class-wise PDF. It means that It means that the things that I have covered this class, I'm going to give you the PDF.
Okay,
Right after this class, I'm going to give you the PDF. Don't worry
thank you.
about that. Solving quadratic functions. We have solved quadratic functions in which you are really a master of. You are really a master, a boss of quadratic formula. You know better than me and completing the square, but maybe not that much effective all the time. Plugging in answers in effective in some cases where the where solving problems are pretty time consuming. We do that. That's a very efficient technique. Undefined functions, which I've discussed earlier, and the last one, but not the least one, the extraneous solution. So the thing that we have left, that is basically synthetic division, which we are going to talk about in our next class. We're going to start. But the things we have, the things that we have covered so far, the things that we have covered, the topics, the chapters we have covered so far, we have some problems, some real time math strategy problems, Please solve these. These are the problems you're going to solve, you're going to see in your exam hall. These are the problems you're really going to see in the exam hall. So in this PDF, what you are just watching, we have every single problem, and we have every single solution for that problem. And you just need to focus on the chapter end problem, because this is the chapter end problem, and you just really need to cover on them, because these are really so important. Please practice drill 1, practice drill 2. Do it. Solution, we have problems and we have solutions. This is basically the solutions. So this is all for today. And most importantly, you just need to practice. You really need to practice, because if you really don't practice, then you really cannot be a good mathematician, at least.